Hi everyone, thanks for watching my screencast on integrating fun challenges into the science classroom in 10 minutes or less. I'm Kent, and if you tuned into the last screencast, we talked about how I find it so awesome to teach in a class full of superfans because superfans are passionate about their stuff. They're willing to go that extra distance to learn just a little bit more about that thing that interests them. And in the last screencast, we also talked about how to develop superfans, we need to give students the right type of challenges. Challenges like solar ovens and balloon-powered cars, challenges where students can build prototypes, test, measure, and improve. But of course, one major obstacle we identified last time was that these challenges take a lot of time. And of course, there's also something called the curriculum we need to teach. So, how do we make maybe smaller challenges that accomplish the same goals as larger challenges, but take less time? To do this, we need to give our students puzzles, but of course, the right type of puzzles. And the right type of puzzles are ones that fulfill these four goals. They are quick, they're skills-based, meaning that there's no kind of specific knowledge we need outside the question to answer to solve the puzzle. There's a building and testing aspect to it. And puzzles need to be logic-based. That means that there must be like an if-then condition aspect to it. So for example, math has this in spades. Math has Sudoku puzzles, they have Ken-Ken, they have straights, they have whatever this thing is, but the common thing in all these puzzles is that they're based on skill and they're based on logic. That means that, like for example, Sudoku, there are certain conditions there. There are certain numbers that can appear in a row, there are certain numbers that can appear on a column, and based on those conditions, I can only put a certain number in a certain square at a certain time to make things work. Okay, so math has this in spades, in their puzzles. So what about science? Are there logic puzzles for science? And oddly enough, the simplest place to find logic puzzles for science is on the LSAT. The Law School Admissions Test has a logic games section. This game is formally known as the analytical reasoning section of the LSAT. These games fulfill these four kind of goals or conditions of a good puzzle. So I'm going to give you a quick crash course on LSAT logic games and show you how it kind of links into these goals of building and testing and logic and analysis. So let's go over an example. All right, so your mind is going to be blown. This is going to be really stretching your mind today. All right, so here's our passage. All right, so Sam brings exactly one sandwich to school for lunch from Monday to Friday. There are 3 sandwiches he chooses from. There's tuna, ham and cheese, and PB&J. When choosing which sandwich to bring to school, Sam follows the following conditions. All 3 sandwiches are brought to school at least once per week. Ham and cheese is brought exactly once. No sandwich can be brought on consecutive days. Ham and cheese can only be brought after tuna has been brought. PB&J is brought immediately after ham and cheese. And a sandwich brought on Monday cannot be brought on Friday. So that's my passage. Those are the conditions. And here's the question. If PB&J is brought on Wednesday, what else must be true? And those are your 5 potential answers. Now, your mind is probably tired, or your mind is probably blown, like what the heck are they asking? And so I'm going to, again, crash course, I'm going to show you how to solve this puzzle. And the first thing we always do is we build a model of all the conditions. And here's the model, all right? So let's build a model. So we're going to write out Monday, Tuesday, Wednesday, Thursday, Friday, okay, 5 days of the school week, okay? And from the conditions above, okay, we can actually map out a few things. We've actually learned from, for example, from condition 4, we've learned that ham and cheese will never be brought on Monday because according to condition 4, ham and cheese can only be brought after tuna has been brought. So therefore, ham and cheese can never be brought on Monday because tuna cannot precede it. Similarly, we've also learned that ham and cheese can't actually be brought on Friday, right? Because according to condition 5, PB&J has to follow it. Okay, so we can't bring ham and cheese on Friday because there's no PB&J following it. Okay, so what we've learned from these conditions is that in fact, ham and cheese can only be brought on Tuesday, Wednesday, and Thursday. Okay, now there's other things we can stack on this. There's more elaborate systems we can stack on this. And if you search LSAT, logic games, and how to solve, people will teach you this. But let's go with the most simple map, okay, simple model. All right. Now let's go to the question. Okay, back to the question. If PB&J is brought on Wednesday, what else must be true? All right. So we're gonna build another model now. Okay, this is a model based on the condition PB&J being brought on Wednesday. So let's put PB&J on Wednesday. What else must be true? What else can we stack on here? Well, let's say ham and cheese is brought on Tuesday. Okay. Now, ham and cheese can only be brought once in the week. That's one of the conditions. So now all the other slots must be filled by tuna or PB&J. All right. So tuna has to actually precede ham and cheese. So that means that tuna is brought on Monday. Hey, that was easy. Okay. So now what goes on Thursday, Friday? Okay. We know tuna and PB&J have to be there, but which goes in what slot? Okay, and the answer is, in fact, that tuna has to go on Thursday and PB&J has to go on Friday. Okay, remember, sandwiches cannot be on consecutive. The same sandwich cannot be on consecutive days. So that means that PB&J can't be brought on Thursday. Okay, also, tuna can't be brought on Friday because the same sandwich cannot be brought on Monday and Friday. That was one of the conditions in the question. So this is the model we've come up with, and in fact this model, the answer to this model would be D. The answer to the whole question is D actually. PB&J is brought on Friday if PB&J is brought on Wednesday. Pretty cool, right? Anyways, your mind is probably blown, you're probably super confused. I totally get it, all right? That was the first way I felt when I did these questions. But as you get into it, as you build more and more models, as you break down a question, as you analyze a question, it gets a lot easier. Okay. Now you're probably wondering, hey, is there another model that can potentially answer this question? So let's build an alternate model and see if it works. Let's see if any alternate models out there works. All right. So let's build this again. PB&J on Wednesday. What if we brought ham and cheese on Thursday? Okay. Well, PB&J has to kind of follow it. So PB&J will be on Friday. Now, again, ham and cheese can only be brought once. So that means that tuna and PB&J are going to be brought on Monday and or Tuesday. And there are two possibilities. Row 1 or row 2. And neither possibility works out. Right? First row, PB&J is brought on Monday and Friday. Well, according to conditions, that can happen. The same sandwich cannot be brought on Monday and Friday. The row 2, okay, or half of the second row and the rest of row 1, won't work because PB&J or the same sandwich cannot be brought on consecutive days. So in fact, there are no alternate models. This is the only model. And from this model, we can answer the question. Okay? I know, mind blown, okay? Or just super confusing. Now, besides analyzing conditions and coming up with models, the other beauty of these puzzles is that you can actually ask multiple questions off the same conditions. So for example, we can ask this question off the same conditions, right? If ham and cheese is brought to school on Wednesday, what cannot be true? Okay, what must be blatantly false? And there's 5 potential answers. And same thing, we're going to create another model. Okay, and we're going to solve the question using that model. I'm not going to go step by step with you. Here's the model that we constructed. That's the only one that works, right? If ham and cheese is brought on Wednesday, that fulfills all the conditions. And the answer is E. Now, I love these logic games, okay? I'm using them more and more in class this year because of the analytical reasoning of analyzing a problem, looking at conditions, building models. They're quick in the sense that 5 to 10 minutes, right? Bell ringers at the beginning of class. They're challenging. And they're skills-based. They're logic-based, right? Kids are really going to have to think about this. There's no specific knowledge required. Now, if you want to find more of these LSAT type of questions, I suggest you do a search online, LSAT logic games, if you want more samples, and look for ones with solutions, because that's really going to help you learn how to do these. Okay. Also consider, if you want more logic games in different style, consider looking at the Riddler section on 538.com. These are also logic-based questions. They're more geared towards high school students. Okay. There are new ones that are published weekly. Solutions are provided, and they have hundreds of questions. Okay. Now, you're probably wondering, all right, Ken, puzzles are great. I get it. But is there a way of tying puzzles to curricular content? Because that would really be awesome if we could find a way to get curricular content, puzzles, and put them together. So how do we do that? And that's going to be for next time. Okay, how do we connect analytical reasoning, aka logic games, to curricular content? That's for next time. Thanks for watching this screencast. I hope you stay tuned for the next episode, which will hopefully be coming out soon. And I'll see you next time. Have a good night.